What is up, my A peeps? Okay, we are going to do lipids today, and lipids are fat. P-H-A-T. Here's the things we are looking for. Don't forget, we want to figure out what the structure of them is. Can we identify a picture of them? What is the monomer? And lipids are a little funky, but we'll talk about it. What are some polymers? What are some monomers? Examples, what are the functions, and is there directionality? Okay, so let's start this bad boy up. Okay, so first off, lipids. Their basic structure is this long hydrocarbon chain. So hydrocarbon H's and C's. We're talking about hydrocarbon chains. And so this part of here, right? Pew, 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 pew. Okay, this little section here, pew, 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 and obviously you can see them here. Those are all, hydrocarbons. Okay, so the function of them is very widespread. They are things that make up cellular membranes. They are things that make up different hormones or steroids. They are things that are fats, which would be stored energy, which our body can break down if we have depleted our energy sources, like the glucose or carbohydrate sources that are the quick energy. Okay, so in general, though, lipids are really cool because they're something called nonpolar. And so you're all like, where have I heard this before? Oh, I heard polar when we talked about water. And so if you have water, which is polar, and now we have lipids that are nonpolar, these two things are not going to mix, okay? Lipids do not like water. They are typically hydrophobic, with the exception of one fancy lipid called a phospholipid. It's this guy right here. And he's unique because he definitely has the hydrocarbon chains, which are nonpolar, but he has a polar head region that actually can attract to water. Okay, so super unique. Lipids are, there's a pretty big wide range of them. The three main types of lipids that you guys are going to be responsible for are phospholipids, triglycerides, and steroids. So let's talk for a second, okay? We can never forget about how the structure of our lipids forms, okay? And so what we care about and how we link up our lipids, where the linkage comes into play is whatever hydrocarbon chain, okay, we attach to whatever head we are attaching it to, okay, or whatever like secondary component it's attaching to. So dehydration synthesis occurs. The fancy bond name here is called an ester linkage. Okay, so this is now an ester linkage that binds it to a glycerol, and we do that 3 times. So we remove 3 waters, and now all of a sudden we have a triglyceride. Or a triglycerol, okay? Again, so depending on what we attach the hydrocarbon chain to is what determines what type of lipid it is, okay? And all of them are going to attach through ester linkages, okay? So again, they are constructed from 2 types of smaller molecules. One of those is the glycerol, that's like a head, and then obviously those fatty acids, hydrocarbon chains, okay? So again, we are using dehydration synthesis to make these things happen. For a triglyceride, we have 3 of these ester linkages, which means we remove 3 water molecules to actually bind those things through the process of dehydration synthesis. And then the hydrocarbon chain is not susceptible to bonding. Okay, so the water H bonds to another water and excludes the fats completely. So that's really cool and really interesting. That again, we have this concept of hydrophobicness in water, which means that it is not going to bind to water at all. Okay, it's going to actually repel water. It's scared of water. Hydrophobic, does not like it. Okay, because it is nonpolar. All right, so some of the major functions of fats, we have energy storage. This is going to be one that we see a lot of, energy storage. That's those triglycerides are definitely good for that. Humans and mammals, we have this awesome, nice adipose layer, and that adipose is going to help cushion us and keep us warm and insulated, and it can also like protect our vital organs, which is really nice of them. And so there's lots of good things that lipids do for us. So they get a bad rap because they're called fat, but they're cool, like PHAT. All right, so let's talk about those triglycerides a little bit more, okay? There are two types. There's saturated and unsaturated fat, okay? So when we talk about this in regards to like our health and stuff, what we like to see is we're all unsaturated fats. Those are the healthy kinds versus saturated fats, which are the not so healthy kinds, okay? So we like to compare and contrast. So like what makes one saturated versus what makes it unsaturated, okay? So typically where you're going to find saturated fats are going to be in our animals, okay? So animal byproducts might have saturated fats in them. Meats might have saturated fats in them. And this is a perfect example. Like bacon grease, if you let it sit for a really long time, it's going to solidify, okay? It's not going to continue to stay a liquid if it gets back to room temperature. And that's a saturated fat. That's one quality about a saturated fat, is that at room temperature, it becomes kind of solid. Versus an unsaturated fat, which we're going to find in a lot of plants, okay? So these are now our vegetable oils, canola oils, those are all plants, coconut oils, all of these things that are more liquids at room temperature, okay? So our oils. So here's the structural differences down here, is that a saturated fatty acid has the maximum number of hydrogen bonds possible, okay? And there are no double bonds, okay? So it's just going to be straight across, okay? An unsaturated fat, however, can have one or even more of these things called a double bond. So let's see what that actually looks like, okay? Right here, you can see our double bond, and what it does is it creates a kink in our fatty acid chain and kind of like changes its direction. And so that's going to be our double bond, which is going to create our unsaturated fat, okay? A way that I like to remember it is that if it is straight across a saturated fat and all of them are straight across, they're going to stack really nicely. And when we think of like holding together, we think of solids, okay? So really nice, sturdy, solid, like a butter, like a saturated fat. Okay, versus something that it's kinked, we can't really stack those nice, so they're going to be all mumbo jumbly and actually not be able to kind of stack on top of each other. And so those are going to stay liquid, okay? And that's just how I like to remember it, okay? So that is our saturated versus unsaturated fat. Those are our triglycerides, and those are the ones that we're really going to zone in for this particular section. Okay, we're going to come to phospholipids again, and we're actually going to come to steroids again later when we get into different units. But for right now, let's really make sure that we understand and we know triglycerides. Two types, saturated and unsaturated. One is from animals, saturated. One is typically found in plants, unsaturated. Okay, one has no double bonds, saturated. One has at least one double bond, and that would make it unsaturated, okay? All right, just to give us a little preview of what we're getting into, a phospholipid is a second type of lipid that we like to talk about. And so here's the really unique thing about a phospholipid. This particular lipid is going to make up a cell membrane. So we've got tons of these all in our cell membrane. And they have, again, the hydrocarbon chain. That's the hydrophobic part, meaning it does not like water because this is nonpolar. But this one's unique because its head, where we saw a glycerol in the triglyceride, now we're going to use a phosphate group, okay, that's going to attach to it. And this phosphate group is actually polar. So it will attract to water. So how this works is these lipids line up with all those hydrophilic, the water liking parts, the phosphates, oriented towards the water on the outside of the cell and the water on the inside of the cell. And all of the hydrophobic parts like to hide behind those hydrophilic heads, and they will orient towards the middle, okay? So none of these are actually stuck together. They're kind of just attracted towards each other, and they're this thing called a fluid mosaic model, where they've got these lipids that form this cellular membrane, and they keep some substances out and they let some substances in, and we'll get to that a lot later and kind of zone in on our cellular membrane, but that's our lipid, and how it plays into it now is that it makes up this thing called a cellular bilayer, where we've got a layer of lipids oriented one way and a layer of lipids oriented the other. Now, what makes these so cool, I'm going to direct your attention down here, is that these types of lipids are a amphipathic, molecule, which means that it contains both that polar and that nonpolar side. Okay, so that's just the fancy word, amphipathic molecule, meaning that it's a polar side and a nonpolar side. Okay. All right, and our last type of lipid, okay, are steroids. An example of such is cholesterol. Okay, so you've heard of cholesterol. Here's where you've heard of cholesterol. Hey, high cholesterol is bad. It clogs your arteries. Well, that would make sense because it's a lipid, it's a fat, and lipids are typically kind of sticky. Okay, but actually, we need a certain amount of cholesterol. It's actually found inside of those cell membranes, and so we need it to help us kind of create some support for those phospholipids that are being held together. Okay. Also, it's a lot of steroids, because again, they have that hydrocarbon skeleton type thing, but they are not really like crazy long chains. They're a little bit more coiled on fused rings, and so they're still classified as that, and mostly because they're hydrophobic, meaning that water they do not like. They repel water, okay, and they'll stay separate from those waters, okay. And then a big thing to kind of keep in mind is that steroids, a lot of examples of steroids are actually hormones. And that's super important because we're going to create hormones in parts of our body, and we're going to ship those hormones to other parts, and we don't want them like dissolving in our, in all of the water that is found in our body. We want those to actually make it there and actually perform the chemical signal that they need to perform so that, things actually happen and go into play. So I hope that helped. I hope that you were able to find what the structure of them was, the basic structure, hydrocarbon chain. I hope that you were able to find the monomer of that and like identify what that picture looks like and see it in your mind. Some examples of some polymers, so our phospholipids, our steroids, our things like that are all these individual little things that are just put together with those hydrocarbon chains. And then what were the functions of each of those three that we talked about? And then any directionality is just how we bind to that head, that specific head, whether it be the phosphate group to make a phospholipid, whether it be the glycerol to make a triglyceride, or whether it be the way we bend it to make it a steroid or a hormone. Okay. Hope you guys are doing awesome. I sneezed right there at the end of my recording. Have a great rest of your day.